So far, we have learned about variety of transformations, whether they are rigid transformations or not, on polygons, squares, triangles, quadrilaterals, etc. Right? Now, we are going to apply the same fundamentals we have learned so far on non-polygons, meaning we will apply those transformations on straight lines or circles because those are classified as non-polygons. So, let us best understand this topic with the help of some examples. So our very first task is that we need to obtain a line parallel to a given line by applying relevant transformations. Okay. Now, we have not been told any specific transformation that we can use. We can pick and choose whatever we want. Our objective is simple, that we want to obtain another line which is parallel to this given line segment AB. All right. So I can simply take this object and move it 4 units or 5 units or 6 units, whatever, in the direction parallel to x-axis, and I will obtain a line parallel to this given line, right? Or I could use some other translation, that I could move it in a direction little bit to the x-axis and then I apply a vertical translation like this with a combined effect of moving this line parallel to the line segment AB. This is also parallel. The new line segment that you just created is also parallel to the line segment AB. So that is one way. What if I make my y-axis, which is the vertical axis, okay, this axis as our mirror line, okay? In that case, you will obtain a reflection of the line segment AB, and let's say that this is the line segment PQ. Now, this is precisely at the same distance, the line segment PQ from the mirror line, as the line segment AB was, right? Let's say this distance is d units. But the fact is, the line segment CD is parallel to the line segment AB that was obtained by translation, and the line segment PQ is also parallel to the line segment AB that was after applying a transformation called reflection. So there are more than one ways to obtain a line parallel to a given line. So now let's take a look at a different example. Alright, take a look at this example. We have to carry out few things here. Apply following transformations to a given circle. First is translation by some units, then we have dilation by some units, and then we have to answer these 3 questions. Okay, so let's take one step at a time. Let's define our axis system, and let's say this is in centimeters, okay, to be consistent with this problem statement. Alright, now the first step is translation by plus 2 centimeter along the x-axis. Now, since this is specifying plus 2 centimeter, that means whatever is the location of the center of this circle, we will move in a direction, positive direction of x-axis, and that will be from left to right, correct? And then we will move 2 units precisely, and this is 1 centimeter and this is 2 centimeter. Now, this is the center of my circle, right? Precisely here. So let's do this. Let's take this object and move it in the direction 2 units to the right. And this is my new location of the center. So this is my old circle and this is my new circle after the first transformation. So our second step is dilate by a factor d is equal to 0.6. Now, since we are not specifying dilation along x-axis only or y-axis only, that means we are applying dilation on this entire object. And since the d is equal to 0.6, which is less than 1, that means you are compressing this object, right? Now let's select this object and reduce the size by a factor equal to 0.6. That means the new object will be of size 60% of the original size, and this is my precisely 60%. Okay, now you're done with the dilation. Let's answer the questions that you have. Is the transformed circle congruent to the original circle? Well, this is my transformed circle after my step 1 and 2. This one right here. Do you see that these 2 circles are congruent? Absolutely not, because the circle 1 is visibly bigger than the circle 2, right? Hence they are not congruent. So our answer is not congruent. Okay. Second question, which transformation could give us a congruent circle? Okay, there are many. There are 3 transformations that could give us a congruent circle: a translation, a rotation, or a reflection. if you were to reflect the circle, which was the old circle in the red boundary, along the y-axis, then you would obtain something like this. That this new circle that you obtain after reflection would be positioned at a distance, precisely at the same distance from the mirror line, which is the y-axis, and the radius or any other dimension of this circle will be identical to this original circle that we label as circle 1. So these two circles, let's say circle number 1 and circle number 3, will be congruent. You could also reflect it along the x-axis and you will still obtain the same answer. So could we obtain a congruent circle by translation? Yes, absolutely. We could take this circle and we could move it anywhere along this xy coordinate plane, whether at this location or in the third quadrant. Let's say this is my new position after translation, right? The circle number 4 in this case will also be congruent to circle number 1. So there are multiple ways you could obtain a congruent circle. So the third question, which transformation could convert a circle to an ellipse? Okay, let us do this. Let's first clean up all of this so that we could answer our third question in a little bit neater way. So here is my circle back to its original condition without any transformation, okay? Now let's try to answer this question, that which transformation could convert this circle to an ellipse. Now there are two ways that we have learned about a transformation called horizontal or a vertical stretch. So let's do this. Let's apply a horizontal stretch only. In this case, I'm stretching this object to a certain factor. Now, how long or how big is this stretch? That doesn't matter. The objective is to demonstrate that when you apply a transformation, something like this, in which you are stretching an object only in one direction, then it would convert that object, this circle, into an ellipse. Okay. If I reverse this transformation, I could apply the same thing but in a vertical direction, that I could stretch this object in the vertical direction and I would still obtain the same result, right? So this is my second kind of transformation. So there are two ways that would convert this circle to an ellipse. It would be either a horizontal or a vertical stretch. Okay. So the key point you need to take home from this exercise is that a clear distinction you need to keep in your mind is that one set of transformations, the translation, reflection and rotation, these three transformations will be called as rigid transformations because they do not change the size or shape of any object. Okay, any other transformation would result in a change in the size or shape of the figure we are talking about. Okay, with that we take a pause here, and that concludes our discussion on transformations on non-polygonal geometric figures.